Sine, cosine, and tangent ratios, numbers for side lengths. Sine, cosine, and tangent are the first three and the three most important trigonometric ratios. The idea of trigonometry is to codify the idea of similar triangles. Specifically, two triangles are similar if there are two pairs of angles that correspond between the triangles. If you have a right-angled triangle and that you know one other angle in that triangle, this triangle is similar to every other triangle that is a right triangle that has that same one angle. So the idea of trigonometry is to simply create a table of every single possible combination based on the measurement of that angle. We often use the Greek letter theta. Almost all American mathematicians, physicists, and engineers call this theta. It should be pronounced theta. I'm not going to get into the mispronunciation of Greek letters in the sciences. But the Greek letter theta kind of looks like an O or a 0 with a line through it. Just a variable. We use theta to represent angles very frequently in mathematics because in vector analysis and in engineering, we kind of run out of letters to represent all the things we're trying to represent. So we start borrowing stuff from the Greek alphabet. Angles are a really common place where that happens. So as soon as we have that angle known, we know that this right triangle is similar to every other right triangle that's out there, which means that the side lengths are in proportion. If I take a ratio of any two of the sides of this triangle, it will be the same as that same ratio on a different triangle, as long as it's a right triangle with that same angle theta. Now we have to be a little bit careful here. The side opposite the right angle is still going to be called the hypotenuse. But now we have oriented this triangle. So we don't just have two legs. We have a leg which is opposite the angle we called theta, and we have another leg which is adjacent to the angle we called theta. And no matter how we rearrange our triangle, we can always pick out an opposite leg, an adjacent leg, and a hypotenuse. As long as we have a right angle somewhere in the triangle, and we have an angle that we can call theta. The hypotenuse is the side opposite the right angle. The opposite side is the leg opposite the angle theta, and the adjacent side is the leg touching the angle theta. Right? So the adjacent side is between the right angle and the named angle. The opposite side is the one away from the named angle, and the hypotenuse is the one away from the right angle. No matter how you orient your right triangle, you will be able to find and name those three sides. Just knowing you have a right angle and knowing that there is another angle in the triangle we care about. All right. So any combination of two of these sides, if we take the ratio, we will get a value that is the same for every triangle that is a right triangle that has that angle, no matter how big or small you make the triangle. That's the whole idea of similar triangles. And these ratios all have names that are hard to remember and hard to pronounce. We have the sine, which we write sin as a function of theta. And the sine is defined as the opposite side divided by the hypotenuse. The cosine, which we abbreviate cos as a function of theta, is the adjacent side over the hypotenuse. And the tangent, which we abbreviate tan, a function of theta, is the opposite side over the adjacent side. These three definitions are worth knowing. If you take any course that has trigonometry or precalculus as a prerequisite, you need to know these three definitions offhand. They will come up so quickly that if you don't know what you're doing, you will be completely lost. You need to know that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And these three ratios are every possible combination of two of the three sides of a right triangle. But they aren't every possible ordering, because we could look at opposite divided by hypotenuse, we could look at adjacent divided by hypotenuse, we could look at opposite over adjacent, we could also flip all three of those over. So there are three other common trigonometric ratios. There is the secant SEC of theta, which is the hypotenuse over the adjacent side. That's the reciprocal of cosine. There is the cosecant CSC of theta, which is the hypotenuse over the opposite side. That's the reciprocal of sine. And there is the cotangent, COT of theta, which is the adjacent side over the opposite side. That's the reciprocal of tangent. Secant, cosecant, and cotangent come up less frequently. In maritime navigation, the secant was a very useful and very valuable function, which is why that's the thing that we talk about involving hypotenuse and adjacent, and cosine is kind of a secondary thing. Since then, the idea of vector analysis became incredibly important in physics and engineering, and cosine is far more important there, which is why cosine made the top list of the things that we are going to be studying. You'll also notice if you look at your calculator that your calculator has buttons for sine, cosine, and tangent. It almost certainly does not have buttons for secant, cosecant, or cotangent. The last thing I want to mention about the names of these ratios is take a look at the three ratios that start with co. And look at the same ratio that doesn't have that co in it. Notice that if hypotenuse is in the ratio, it's in the exact same place. If opposite is in the ratio, it got replaced with adjacent. And if an adjacent is in the ratio, it got replaced with opposite. The co-functions switch which side we are talking about as the opposite leg and which side we're talking about as the adjacent leg. Those kinds of tricks really helped me when I was first learning trigonometry to keep straight which of these angles is which. But as a simple example, let's take a look at a particular triangle, maybe one that looks a little bit like this. Let's go ahead and name this as angle theta, and let's fill in the sides. That's not supposed to be a 5. That actually looks like a 5. This is side 13, and this side has a length of 12. The sine of theta is the opposite side divided by the hypotenuse. And I'm not paying enough attention. The triangle that I drew is literally impossible because the longest side of the triangle was not the longest number. Sorry, I drew this triangle backwards. Let's try it in this order. Sine of theta is the opposite leg divided by the hypotenuse. The opposite leg is this guy over here, which we've written with a length of 12, and the hypotenuse is this guy over here, which we've given a length of 13. So if I take the opposite divided by hypotenuse, I get 12 over 13. The cosine is the adjacent side divided by the hypotenuse. The side adjacent to angle theta is this guy here, the 5, and the hypotenuse is still 13. Tangent is opposite over adjacent. The leg opposite theta is this guy over here of length 12, and the leg adjacent to theta is this guy up here with length 5. So with that, reading from the triangle, we can get the measures of these three trigonometric ratios. Generally, leaving things as fractions, leaving things as improper fractions is the way we'll go about this.